In level 1, we didn't have to multiply either of the equations by any number. It was just set up so that one variable would already cancel. In level 2, one of the equations had to be multiplied by some number to get a variable to cancel. And now in level 3, both equations are going to need to be multiplied by some number. So looking at my x's for this first example, 3x and 5x, there isn't a whole number I can multiply 3x by to get 5x. And then looking at the y's, 4y and negative 3y, there's no whole number I can multiply 3 by to get 4. So both equations are going to have to be multiplied by something. And you can either get your x's or your y's to cancel. It doesn't matter which. If I wanted to get my x's to cancel, I could multiply my top equation by 5, and my bottom equation would then need to be negative, so I'm going to multiply it by negative 3. And if I do that, my first term on the top will be 15x, my first term on the bottom equation will be negative 15x, and the x terms will cancel. So I multiply the top equation by 5, and we get 15x plus 20y equals negative 10. And then in the bottom equation, negative 3 times 5x is negative 15x. Then we get plus 9y equals positive 39. Now when I add my two equations together, the x's cancel. Adding the y's together, we get 29y equals 29. Divide both sides by 29, and y equals 1. And then it's the same steps as before. From here, I plug 1 in for y in one of the equations. So I'll use the top equation. 3x plus 4 times 1 equals negative 2. That's 3x plus 4 equals negative 2. Subtract 4 from both sides, and we get 3x equals negative 6. Divide by 3, and x equals negative 2. So my answer, x is negative 2, y is 1. And then I'm going to check my answer in the second equation. 5 times plug negative 2 in for x, minus 3 times plug 1 in for y. I hope I get negative 13. I get negative 10 minus 3, which is negative 13, so it worked. In this next example, my equations aren't quite in the right form that I need them to be in. I need it to always be, like if we look at this for example A, the x's were lined up, then the y's, then the equal signs, then the numbers. This next equation, it's not in that form yet. So taking the top equation, I need the 4y to move over to the other side. So I'm going to subtract 4y from both sides of the equation, so I get 2x minus 4y equals 6. And then the bottom equation is also not in the right form. I need the 6y to go to the other side, and I need the minus 9 to go over to the right side. So I'm going to subtract 6y from both sides, and I'll get 3x minus 6y. And then I'm going to add the 9 to both sides, and I'll get a positive 9 on the right side of the equation. Now I need to figure out how to make my variables cancel out. So the top equation, again, if I want my x's to cancel, it doesn't matter, you can make your x's or your y's. I'll make the x's cancel. To do that, I would multiply the top equation by negative 3 and the bottom equation by positive 2, and that would give me a negative 6x on the top, a positive 6x on the bottom. So negative 3 times 2x is negative 6x, negative 3 times negative 4 is positive 12y, and negative 3 times negative 6 is negative 18. Then for the bottom equation, 2 times 3x is positive 6x. 2 times negative 6y is negative 12y. And 2 times 9 is positive 18. Now, when I add my equations together, the x's cancel and the y's cancel. This happened before, but this time the regular numbers also cancel, and we get something that is true. 0 does equal 0. And whenever that happens, there are infinitely many solutions. And what this actually represents in a graph is these two equations are the same, represent the same line right on top of itself. So imagine if you graphed the same line right on top of itself. In how many places do the lines intersect? Well, they intersect at every single point on the lines. So there are an infinite number of points of intersection because they represent the same line. So the answer is infinitely many solutions when both sides of the equation cancel out and you get 0 equals 0.